Welcome to this another session, guys. So in this session, we will try to understand, is there any other model exist apart from OSI model, and which is the model which is getting used mostly in the real time network, right? So these two questions we will try to answer, and we will also try to understand what are the other models, other famous models. Okay, so let's start. So the other model which is used widely along with OSI is TCP IP model. Okay, so we have OSI and we have another model, TCP IP model. So OSI model, this is the layer architecture of OSI model. We also seen it, right? So we have total 7 layers. 7 layers we have in OSI. Okay, and this is a TCP model. TCP model. Okay, this is OSI model. Okay, so TCP model, if you see, it has some less number of layers. So it has altogether 5 layers only. So we know, right? TCP is a protocol also. So this model is evolved from this protocol, and it also uses the IP protocol. So TCP and IP combination is major in this TCP IP protocol. Okay. Now we also know that TCP was, this protocol was evolved in around 1980s around, right? In 1980s by DARPA, correct, which is a Advanced Research Project Agency of USA. So they are the one who funded the development of TCP IP model. Okay. So this was a somewhat background. Now let us come to the layers. Okay. So one thing is very clear. In OSI we were having 7 layers. In TCP we have 5 layers. So less number of layers, easy to implement, right? It's directly proportional. So this is very easy to implement. Okay. And OSI layer is more over a theoretical layer. Theoretical model. It's a theoretical model. Means it's an ideal model. If you tell somebody something, right, then we mostly tell it in an ideal way, that it should happen in this ideal way. So OSI is just like that. It's a theoretical ideal model. Implementing OSI can be a tough job, but implementing TCP is an easy job. And TCP is basically evolved from the TCP protocol, right, which already many people were using. So it is more real time. Okay, it's a more realistic and real time. And most of the network, most of the internet of the globe uses TCP IP model only. Okay. So again, it has 5 layers. Each layer does its own task. So application layer, we have seen, right? The user communicates with the application. He upload the file, he do emailing, he do web browsing, he do file transfer. All these tasks will come into application. So it provides a protocol for user level communication, handles data formatting, encryption, compression, everything, whatever these 3 layers does in OSI, this application layer does the same thing in TCP. Okay, then transport layer is whatever this transport layer does, same thing the transport layer does. So what transport layer does is, so transport layer here divide the data into segment, ensure order, reliability, and provide faster delivery. All these things the transport layer does. And a transport layer protocol we have seen, we have two, TCP and UDP, right? These two. If we want acknowledgement, reliable and ordered, error checked messages, then TCP is a go-to protocol. And if we want fast, lightweight, and no guarantee, then UDP is the go-to protocol. Now, this network layer is another layer in TCP that is also sometimes named as an internet layer. Okay. So you will see some of the website call it as an internet layer. So whatever network layer does here, right? Same thing this layer does in TCP. So what it does, it figure it out the best route, best network route to route our data to the destination, right? So that's what the internet layer does. So in that it uses IP addressing, right? It uses IP address protocol. Then it uses ARP, address resolution protocol, to resolve the domain name. If somebody given some abc.com, how to resolve its IP address, all these things, this ARP protocol does that, right? All these things the network layer does it. Okay. So it basically find the best route to send your data across the globe. Okay. Then next layer for us, we have denoted is a data link layer, right? But these two combination layers, again, some people will name it as the only link layer or network interface layer. So whatever happens here, right? Same thing happens here in TCP/IP. So here what we have seen, we saw the use of MAC address, right? So to figure it out the exact device where our package should go, right? That information will be added in this layer, data link layer. At the also at the same time, whatever data is there, that will be represented in the bit format and actually transfer over the physical network. All these things happens in this network interface layer. So these two also sometimes name as a link layer or a network interface layer. So this is what our TCP IP model looks like. It's a very simple, easy to understandable model. So altogether, sometimes you might see that TCP/IP, currently we are seeing 5 layers, but it can be 4 layers, because this two we are combining it to link layer. So we have application, transport, network, and link layer. So some website might tell you it's a 4 layer protocol, 4 layer model also. That is also exactly fine. But under the hood, these 5 layers are working. The internet and all the real world networks nowadays uses TCP/IP. And at the same time, OSI, right? It is actually used for learning, design, explanations, right? So for learning, it will be better, right? As granular as you go, you will understand the criticality and complexity of that step, right? So if you see application, here a single layer, here 3 layers. So you have a segregation here. So it will be better understood in OSI. So OSI is usually, that's why we are calling it as a theoretical model. So this is a basic difference between TCP IP and OSI model. Okay. I thought of covering this topic so that you will have a thorough understanding of all the models, right? So if you like this video, do share, subscribe to this channel, and stay tuned.